Hi and welcome back to another Shouting Electronics. If you looked at my previous video, you would see a problem we had at a client where 230 volts AC found its way onto the DMX line. In the previous video we repaired a DMX controlled relay, and before that, not on video, I actually tested the LED Parcan lights, which are these ones. As you can see, they got a whole bunch of LEDs on them and they are all computer controlled through the DMX line. When I tested them individually, they worked fine. But when I went to reinstall them and put them all onto the same line, it basically stopped working and we stopped getting DMX signal through. So I thought I'll show you what we have discovered, and then we'll have to go and start sorting out this problem. So let me show you the first fitting here. I'll move you in. Okay, so as you can see, sure I'm pointing at the right fitting. I've set all the fittings to the same DMX address just so they should all do the same thing. Let's move this little water tail out the way. So on the fitting we got our DMX input and our DMX output, and also the dip switches to set your channels. You can see this LED is flashing to say that it's getting a DMX signal. If I unplug it, we lose the DMX signal and then the light goes into an automatic mode. Okay, so it's working fine. I've got this nice fading color on here that's looking right. You can see the LED is getting a flashing to say we get DMX signal. Okay, normally in these fittings the input and output are hardwired on the cheaper fittings together. This one either switches it through a relay or has a microcontroller regenerate a signal. If you have one of these, say as a master using the remote input, then it doesn't accept DMX in. But now I'm mainly interested in DMX, so let's take some cables here. I'm going to plug this one into the DMX output of the first light. Okay, you can see we still got the DMX flashing. Going to plug it into the input on our second light here, which is just running its auto mode here. And the second light is fading okay, and you can still see the DMX indicator on the first light. Let me go and plug in the next light in the chain. Okay, so I plugged in the next light. And the first one is still working fine, okay? If you look on the second light, I don't know if you can see it from there with this camera angle, there is no DMX signal light, okay? And the third light's also the same. If I take this DMX out of the first one, plug it into the second fitting, okay? Second fitting's working, third fitting's not. Okay, so the inputs are all working, but I'm not getting any signal through. And it's only when I plug say 2 or 3 together. Okay, so now with them off, it should just be a straight short input to output, but not between the pins. The pins between themselves should actually be infinite resistance, okay? So let's punch out a bit there. Hope I can get this all into the shots. So we'll go for a continuity test, okay? Now your DMX plus and minus lines are pins 2 and pins 3. Let's test here. Okay. So pins 2 and pins 3, you can see it's registering as a short on diode test. Let's go to normal resistance check. Okay. And you can see it's 2.6 ohms, okay? Now that is actually a very low resistance, because say you got 2 lights connected together, and 2.6 is 1.3 ohms, and let's say a 7 volt signal, okay? So let's do some sums. 7 volt signal, okay? Divided by 1.3 ohms, which is what 2 fittings would give us together, is 5 5.3 amps. So basically these two want to source 5.3 amps together. Even one will be about 2.15 amps. And these DMX interfaces with the standard chip in them are only rated at about 60 milliamps. So the fact that this is even providing enough current to let the one fitting detect and recognize a DMX signal is actually quite a testament to this controller by Camsys, this DMX interface. This is the DMX basic interface. You also get the full interface. It's similar, just it doesn't have the time limits, but also they're not designed to send 5 amps or supply 5 amps out, especially through this DMX cable. You're going to have voltage drops and things like that. So we need to see what in these fittings is causing the resistance to be so low that we're trying to source too much current from this driver. So I am going to move you to the workbench. We're going to open one of these fittings and take a look. So it could be the driver chips in these fittings have shorted out, or it could be something else on that circuit. So let's take one of these things apart. And there we go. Let's just get the power cord out the way. And here is your DMX input over here. Let me try and zoom in a bit for you to see. Okay, so here's our DMX input from the jacks on the back, inputs and outputs. There is our DMX driver chip in there. Just point that's right. And as you can see, we do have some Zener diodes there between the jack and the chip. Those could be protection circuits. So it could be, if the voltage goes too high, it shunts it away to protect that driver chip and the rest of the circuit. Okay, let's go through this board here. Well, we got it open. Just so we can... It's always nice to study how other people have done boards and what they do. Okay, so we've got 2 fuses here. Primary and secondary of the transformer. We've got the dip switches and the LED. In auto mode, it's got sound activation, so it's got a microphone here. It's got a 74HCOO. It's got a HA1735B. It's got that driver chip. And it's got 2 chips with version numbers on it and a couple of transistors, voltage regulator, and that bridging out relay or whatever it is. Okay, so let's... The fact that the light fittings, when they get connected directly, is actually receiving a signal and behaving, leads me to believe that it's just something with the board itself. So let's start with these Zener diodes, which if we look over here, here's your inputs. Here's your inputs, okay. Here's our inputs. Our Zener diodes are all across there, which goes to a common rail, so it could be going to a ground plane or something. And they are 6.8 volt Zeners. So let's check our resistance. Just resistance. Even. Okay, if I check 0.7, and that's open. Okay. And that's giving a short on both directions on a few of them. Let's just check what my multimeter's voltage output is on diode test, because if it is more than 6.8 volts, it can trigger these Zeners, and then it will give us continuity anyway. Okay, so my diode test range on this multimeter, on the TA35, is giving out 3.1 volts, which isn't enough to trigger that Zener. So I'm going to rip these Zeners out now, because I've got a few spares here. I've got 60 of the 6.8 volt Zenas lying somewhere. I've got 60 of them. A nice little packet. So I'm going to rip them out, and then we can test them out of circuit and then see about putting new ones in all the fittings. The reason I'm going to do them all, even though this first one checked okay, is just while we got it open, we might as well do it in case we get a problem down the line. Of course, if this does sort it, I'm going to have to test all these and do them all individually. But if it does sort it, I'm not going to bore you with the details of doing each and every fitting. I'll just show you me changing the Zenas on this one, and then I'll climb and do all the other fittings. But let's pull the Zenas out first and see that there's nothing else in the circuit that's conducting. Nothing shorting there. Okay, now let's do the multimeter thing. Some diode test. If I want to just check the inputs and the outputs separately, that's the easy job, because the inputs and the outputs, 1, 2, 3, see their inputs and outputs, that's one, and outputs are there, no continuity. That's the pass-through and that's the pass-through. Okay, so if I go on the outer two, nothing. Okay, this is all one side, so it could be input or output. Let's see the other side, input or output. So that actually looks clear. Don't worry, this is a painted plate, so this won't affect our readings. Straight away, dead short. Both directions. And if it's done it to one diode, I'm sure it's done them to all. So we're going to, these diodes sacrifice their lives to save the rest of the board and the drivers and that on this board. So I feel confident if I just put new diodes in this board, we should be good to go. So if you need close to a breakpoint, just take a look. Okay, so just carefully hold the diode at the center, bend the legs over, put them in, make note of the orientation where the band is. Open, open. So you see I'm spreading the legs there. So the nice thing is we just do 5 at a time, whack it over, solder it, throw them down on your lap. That's what it's good to do. No, so these are 6.8 volts Zenas. I think the DMX line's running at about, well, it's definitely less than 6.8 volts, so else these guys would start conducting. Which they did, but the power they had to dissipate for 230 volts was just too much for it. Okay, so there I've got all 5 of them neatly in a row. Hope you can see them up there. Just pushing them flat with my thumb while I spread out the legs. And then we're going to go in and solder them and trim the legs. And when you trim the legs, make sure you catch the little piece of the legs, because it's very painful if you stand on one that goes into your foot. I don't know if you saw that video on one of the other Twitter feeds, from one of the other electronics YouTube bloggers, where they had to have a surgeon come in and move the resistor leg out of their foot. Yeah. So I'm just gently applying some heat and solder. Give it about a second for the solder to wick through to make sure it's getting onto both ends of the plated through hole. That looks good. You can see that they're all there. I don't know if you can see the fillets have come through onto this side, so you just take our cutters. Okay, so that's all done. Just going to give it a little brush of some isopropyl alcohol. A nice rainy day, that's quite good. Give it a good brush. Wax residue, even though nobody's really going to see inside these fittings. Just make sure there's no little piece of solder lying around. Oh, you want to do another resistance check quickly? Or diode check, let's go. Drop my toothbrush. No, I'm not going to brush my teeth with that brush. Okay, so let's go through one side. As you can see, no, you can't see, sorry. Okay. Nothing on those 3 pins. Nothing on those 3 pins. That's where I touched my probes together, so you know that still works. Okay, so let me do this a few more times and then I'll get back to you. Actually looks like rain when it's flashing like this. And I'll look straight into the diodes, which I shouldn't actually do because they are bright. Okay, so I've gone and I've changed the Zener diodes in all of these fittings because all of them were indicating a short on the DMX lines. I've got them all connected up in series. They're all happy. They're all receiving a DMX signal. As you can see, the computer's giving them the same chase. You might see that some of them, like there's not much blue on these top 2 ones, and this one's got a flickering blue compared to the other ones. That's just because of faulty LEDs. That's causing that chain to go out because there's quite a few LEDs in series. For example, the blue ones here and the blue ones here are basically the worst offenders. I think they've got about 2 chains out or 3 chains out each. But the main problem that we had was with the DMX lines, and that is sorted out. So the next step will be to see if the client wants those LEDs sorted out or if they're happy with just having basic color rendering like this. So I hope you enjoyed this video. If you liked it, please give it a thumbs up. Click on subscribe and also click on that little bell icon to be notified whenever we put up a new video. Thank you.